Alright, here's your second round video for the exponents unit. This one is going to be just an introduction or a review of exponential notation when you have the base as a number. This is something that you've probably covered in pre-algebra, but I just want to have a basic overview before we go into exponent rules of just what exponential notation means. So when you have something multiplied over and over and over by the same number, instead of having to write that longhand like 3 times 3 times 3 times 3 times 3, etc., you can write it using what's called exponential notation. And the way that you do that is by writing the number that's being multiplied as what's called the base, and then the exponent is the number of times you multiply it. So let me first do an example, like 3 times 3 times 3 times 3. You could write that as 3 to the 4th power. And so this right here is called the base, and that's the number that you're multiplying over and over and over. And then this up here is called the exponent, and that tells you the number of times you multiply. Okay, so the exponent is the number of times you multiply, and the base is the number being multiplied. And so you should always remember this definition of exponential notation, because when we go over the rules in a little bit, it's very easy to prove all of the rules by just referring back to this overall definition. So let's do some more examples. 7 to the 3rd power, you could write as 7 times 7 times 7. You can do 10 to the 5th power. That's 10 times 10 times 10 times 10 times 10. So again, the number you multiply over and over is whatever the base is, and the exponent is the number of times that you multiply it. We can do one last one here. Oh, darn. Hold on. Okay, and we're back. So the number in the base is the number that you're multiplying over and over and over, and the exponent is the number of times that you multiply it. Let's do one last example. Let's do negative 2 times negative 2 times negative 2 times negative 2. So in this case, the number that we're multiplying each time is actually negative. That's okay. So you put negative 2, but if it's negative, then you want to put it in parentheses, and then the number of times we're doing it is 4. So all these, I could have put the 10 in parentheses also. There's nothing wrong with doing that. 10 to the 5th, or here I could have put the 7 in parentheses. You can put the base in parentheses. There's no problem doing that to the 3rd. But it's not that important if it's just a number all by itself. Whereas if it's a number with a negative sign, then it's often important to put the parentheses around it to show that, let me give you an example. It's different than saying negative 2 to the 4th. And the reason that's different is because of PEMDAS. So if you remember, for PEMDAS says exponents first, parentheses first and then exponents. So here, and then multiplication. So here, this is negative of 2 to the 4th, because you do 2 to the 4th power, which is exponent, before you would do the negative sign. So the negative is multiplication. This means a negative times 2, which is negative 2. This means negative times 2. But here, you're multiplying the 2 by negative first and then raising to the 4th power. So the answer here actually is negative 2 times negative 2 times negative 2 times negative 2, which is positive 16. And the answer here is negative of 2 times 2 times 2 times 2, which is negative of 16, which is negative 16. And so these two things, they're not equal. And so you have to be cautious that if you have something that's negative being multiplied, you put parentheses around it. Okay, so what about exponential notation for variables? So as you transition from pre-algebra into Algebra 1, you're going to be using a lot more problems that are using variables instead of numbers. So the methodology is exactly the same, except instead of having a numerical base, we're now going to have a variable as the base, but the exponent itself will still be a number. So let me give you an example. X times x times x, we can write that as x to the 3rd power, because you have the base, the number that you're multiplying is x, and you're multiplying it 3 times, so you write x to the 3rd. What about y to the 4th? Okay, that's going to be y times y times y times y. So the number multiplied is y, and we're doing it 4 times, so you just write it down 4 times. So what if you had z to the 25th power? Oh my god. That's z times z times z. And then you just go dot, 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 25 times. Okay, so I'm not going to write it down this many times. So if you have z to the 25th, that's part of why exponential notation is used, is because when you have a high exponent like this, it's super tedious to write out the whole thing in longhand, and you can write z to the 25th very quick and easy and show what it means. So let's do one last one. Let's do something with a combination of two variables. What if I have a times b times a? Okay, here we have two different bases. I've got the base a and the base b, and they're all multiplied together. So I can look at each one separately, and I can say, how many times am I multiplying the base a? I'm multiplying the base a 3 times, so that's equivalent to a to the 3rd power. And I'm multiplying that by the base b, and I'm multiplying by the base b 2 times. So you can do a to the 3rd, b to the 2nd, instead of all of these things here. And so it doesn't matter how many different variables you have, you count each one, and you see how many times it's occurring, and that's the exponent for that base. And then if it's a different base, you count the number of times that different base is occurring. Okay. So that's it for exponential notation. It's very basic. The base is the number that you're multiplying, and then the exponent you write kind of as a superscript up here. That's the number of times that you do it. So make sure you memorize that.